Morning everyone, my name is Benedicto and I'm from grade 9. And I would like to present my experiment where the third Newton's law was influenced to the workings of the wind turbine, which turns the generator to generate electricity. So the main topics throughout the presentation is starting from the definition of the wind turbine for daily life, my main experiment about the wind turbine and things that can go wrong in the experiment and how to solve it. So this is my entire framework, introduction, definition, and so much more. So starting from the introduction, I remember that time was a very windy day when I was still thinking of what should I do for the science experiment that could combine both heat transfer and the laws of Newton while still making reasonable use besides from only demonstration. That time I was still doing homework as usual, but then when it was very windy outside, I saw the trees getting blown so hard by the wind that the leaves fell off like it was weightless. And then it reminds me of how the wind works, which is through a heat transfer called convection. Realizing that, I came up to figure out what relates to Newton's law of motion. And the best answer is a windmill or wind turbine because of the special shape of the wing pushes the air down just like on the airplanes or bird's wing, which generates lift. And this is something like the action and reaction effect of Newton's third law of motion. Then there it is. I finally get something that could relate on both heat transfer and Newton's law of motion. The definition: a wind turbine is a rotating machine that converts the wind kinetic energy into mechanical energy. Before the era of modernization, people used these wind turbines for factories and more. But now, most of wind turbines are used for making electricity via electric generators, which converts mechanical energy into electrical energy, which could be used for industrial applications. There are two types of wind turbine: the horizontal axis and the vertical axis, where the horizontal is more widely used and known, while the vertical axis are quite rare and not that much known by a lot of us. Wind turbine for daily life. If your area generates enough wind, home wind turbines can help lower electricity bills by 50 to 90% and provide an uninterrupted power source throughout extended utility outage, all with zero emissions and pollution. But despite from that, a wind power system also greatly depends on the weather outside your house. So when the weather is very windy or is too windy, your house may not be suitable for a wind power system because too much wind is also not good for the system. The physical laws and formula behind the workings of the wind turbine. The blades of the wind turbine involve to the lift created by the airflow, which involves to Newton's third law of motion by the downward force of the air each of the blade creates, which also involves what's called the Bernoulli effect. Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid's potential energy. Bernoulli's equation for incompressible fluid flow is described as lift equal to coefficient times density times velocity squared out of 2 times by wing area. The coefficient contains all the complex dependencies and usually determined experimentally. So you can see on the wing shape over there, where the upper side of the wing creates a faster speed yet lower pressure of airflow, while the bottom of the wing creates a slower speed yet higher pressure airflow. And this pressure difference makes the wing push the air downwards, and due to Newton's third law, which is for every action there is an equal and opposite reaction, the air pushes the wing back up, which creates the lift we are looking for now. This lift is converted into turning motion by the center pivot/shaft the blades sit on, where this turning motion is converted into electricity via the electric generator the turbine is connected to, and that electricity powers up to the lights that is connected to it. Examples of calculation in Indonesia based on the formula above. So based on the Google data of West Jakarta specifically, the wind velocity is about 16 kilometers per hour in average, or 4.444 meters per second. The wing area is 8 centimeter times 2.5 centimeter. Each blade is about 20 centimeters square in area, or about 0.002 meters square. Today we're gonna do full metric. The atmospheric density is 1.16 kilogram per meter square, and the coefficient is 1.65. This is just estimation, it won't be that much accurate as it seems. So according to the calculation based on the data we got previously, the lift is 1.65 times 1.16 times 4.444 divided by 2 times 0.002, which is 0.0378 newtons. So the total amount of turbine torque is 0.00378 newtons times 4, which is equals to 0.1512 newton meters. So this is how the lift calculation and the amount of torque is applied. How does this third Newton's law helps our daily life? From the explanation above, the wind turbine moves to the stream blow of the wind. When the turbine is connected to the generator, it can move the generator itself. Inside the generator, there are some coils of copper wire and some magnet poles, which influences the magnetic field to create electricity. And the electricity is usable on our daily life. So this is one example of the diagram. Okay, so let's focus on my experiment specifically. The methods is the essential components for large-scale wind turbines include the rotor or rotor blades and hub, drivetrain, rotor shaft, bearings, brake, gearbox and generator, supporting structure, tower and foundation, electrical components for control and grid connection. Maybe not for this experiment because we simply connect the generator to the LED lights. Now let's go to the preparation. Finding cardboard box from the back of the house at the equipment room. So we have some of those things from the back of our house. I found the solder from my house garage unused for years, and the glue gun I'm using right now is borrowed from my mom's friend. Getting the electric motor / generator from an old RC car I bought years ago, and preparing some of the other stationary tools like scissors, cutters, rulers, etc. List of materials: some cardboard box, an electric DC motor from an RC car as a DC generator this time, some LED bulbs, and at least 1 meter of gauge wires for the circuit. The procedure. The first part that we built is the electric generator housing. We glued 2 small pieces of cardboard to enclose it. And then we made the tower by rolling a long flat sheet of the thinner cardboard layer. And from that rolls of thin cardboard, we made the base of the tower from small box cut of cardboard, and we stack it and glue it to the tower. The wind turbine tower is done. Now we just simply glue it to a bigger cardboard base for the whole thing. The generator was soldered to a gauge wire, which was cut into a length that is not too long nor too short, and it was then connected to 1 or more LED lights. I have 2 in parallel in this case because I like it better that way, via the solder tool. It was a hard time trying to connect the LED to the wires. They just don't like to be soldered and connected, by the way. And then we built the house with cardboards as a decor, with the side panels that have some windows put on from a thin plastic. And don't forget to put in the LED light inside the house along with the excess wire so that the outside will look much simpler and neater. Build the propeller. To do this, we must take 4 coin-scale cardboard circles and we glue it together with a covering also made by a thinner layer of the cardboard. And from there, we made the main shaft of the turbine. To make the blades, we specifically need the cuts for the lower part of the cardboard. The thinner layer is the upper layer, with the size of 8 cm times 2.5, which is just like what I mentioned earlier, specifically 8 times 2.5. It's not urgent, but we cut other curves on the other end, but it's urgent to add the inner curves on the bottom of the blades and glue them to the shaft with one end on the front side of the shaft, just like this. Front side of the shaft and the other side on the back side. So we make it about like sort of incline. 4 blades is used in this case, but you can either use 2 or 3 or 5 or more, but not too much because you might make the turbine too heavy to turn. Do the experiment by blowing it either with the fan or an actual wind and figure out if the light is lit or not. If it does, then the experiment is a success. The best condition for the windmill to work. Wind turbines work best in rural areas as this reduces turbulence, which is caused by obstacles, for instance, buildings and trees. For best results, an ideal wind speed would reach 5 meters per second. And to measure wind speeds, there are a number of different devices which are accessible to you. Inevitably, with a stronger wind speed, then a higher return is received. Small domestic wind systems are beneficial for those who live in remote areas where electricity mains are unavailable, thus giving you off-grid possibilities. The wind speed increases with height from the surface to the upper troposphere. There are several reasons that explain this tendency. First, especially in the middle latitudes, the pressure gradient increases with height. The height of the troposphere is taller in warmer air, right side of the diagram, since warmer air is less dense and thus occupies a greater volume. Going up in altitude, the pressure gradient between the warm air and cold air increases with height. And to be specific on the diagram, MB equals to millibar. And just like what I said, the lower the pressure, the higher the speed. Then what could go wrong? When this experiment fails, there could be a lot of possible reasons. 1. The generator might not be outputting enough voltage. 2. The propeller may be not spinning fast enough. 3. The LED might be too dim for us to see through the mini model house because, the plastic is quite translucent in this case. So maybe the light is too dim for us to see through the house. 4. Wire connection issue. 5. Hardware failure. And 6. The wind might not be blowing strong enough. In case of a hardware failure, you might need to change either the generator or the LED lights, or maybe even the wire. So yeah. What to do if this doesn't work? When you have blown as much wind as possible to the windmill, try turning it manually with your hand. And check if the LED light turns on when you turn the generator right with your hands. Try both directions because in this case, an LED only turns in one direction of current, which means that if the current is reversed, it won't turn on. And if the lights turn on when you turn it manually, it's good. It means that only the propeller is the issue and you might need to remake it. But if the LED lights isn't in both directions, there must be a problem in the electric circuit. Thank goodness if it's just the wire connection issue where when you solder it back together, it weren't. But if we connect it and it's still not working, either the generator or the LED has something wrong. You might either fix them or replace them. And then we go to the conclusion. The Newton's law involved in this wind turbine is Newton's third law, where it turns by the action-reaction effect. And besides the Newton's law, it also involves the heat transfer, as the wind itself is from one of 3 types of heat transfer, named convection. This convection also exists on water boiling, where the hot water rises to the top while the colder water sinks to the bottom to get heated up again. The wind turbine is a pretty good solution for a low budget and low space source of electric power. It's simple, it's compact in area use, and it can be placed basically anywhere that at least have enough amount of wind to blow on. You might also make flocks of them to generate more power in total from the wind if you want. So that's it for the presentation. Thanks for watching.